Hello and welcome to the Oracle Database World session on business continuity the smart way. My name is Markus Michalewicz. I'm the Vice President of Mission Critical Database Product Management. And the reason why I wanted to talk about business continuity the smart way with you today is because downtime risk exposure is steadily increasing. Downtime risk can not only come in direct risks, such as financial risk, business interruptions causing revenue loss, for example, or unplanned recovery costs. It can also come in indirect risk, customer risk, for example. Customers who've had a bad experience may not return, or widely publicized outages make it harder to attract new customers. And for those of us who operate in regulated businesses may also face penalties for unplanned interruptions. But downtime risk exposure is also a very high risk because it steadily increases with the amount of data managed. And as we all know, the amount of data managed is steadily increasing as well. And that is exactly why Oracle Database introduced smart features back in 2018, realizing that higher risks require smarter solutions. Now, in 2018, I introduced smart features as automatic features that are executed as needed using real-time analysis of data at the moment of execution. Very little did I know at the time that artificial intelligence, AI, and machine learning, ML, would see such a tremendous development over the next 6 years, which is why today I would use a slightly different definition of smart features for this presentation and perhaps even in general, in that smart features use the combined strengths of analytics, statistics, and machine learning, and will eventually be used to provide future smart products. I will also say that today's enterprises need business continuity smart features. But what are business continuity smart features? Business continuity smart features are those features that preserve availability by preventing worse failures from happening. They are features that automate corrective actions to minimize mistakes and/or provide intelligently enriched analytics and diagnostic data for faster root cause analysis. Or in short, business continuity smart features are those features that help you protect your data more effectively. Now, speaking about effectively and efficiency, when it comes to Oracle Database, you really need to use only 3 components for maximal success. The first one is the Oracle Database itself. The Oracle Database itself comes with extensive database automation and inherent smart features, some of which I will talk about in the course of this presentation. The second component are Oracle Engineered Systems. Oracle Engineered Systems come with integrated infrastructure automation and are enhanced with smart features. And already using those 2 components alone will give you a great amount of business continuity, which is why the third component, the autonomous Oracle Database, is a little optional in that regard, but it does provide automated data center and streamlined database operations in the Oracle Cloud. And it uses additional smart features, either smart features provided by the 2 components which I already mentioned, or the Oracle Cloud itself. Because smart features can come in all forms and shapes. I want to give you a very simple example. Historically, in an Oracle cluster where 2-node cluster, the node with the lowest node number would survive fencing. Now, fencing describes the forceful removal of a node in a cluster if there's, for example, a communication interruption, as shown here in my picture on the left with the down arrow in red. Using the rule on the right, in this example, the node with the lowest node number, number 1, on the left side, would survive, and node number 2 on the right side, which is actually running all the workload, would be fenced, meaning it would be removed from the cluster, which means the workload running on node 2 at that moment would be failed over to the first node, which is fine, except it would have been much smarter if the cluster could have realized and recognized where the workload was running, and if possible, let that workload survive. And that is exactly what node weighting, which is the feature name, tries to achieve. Node weighting tries to ensure that most of the workload survives fencing uninterruptedly, and that is smart fencing. Now, I can give you a number of other database smart feature examples, but one that I want to mention explicitly is the blocker resolver, formerly known as Hang Manager. And the blocker resolver is a poster child database smart feature because it automatically and reliably detects and resolves database hangs, including those database hangs occurring between layers, such as the automatic storage management, ASM, and the database layer. Blocker Resolver also resolves application-induced deadlocks, and it locks all detected hangs and their resolution. Well, what makes it really a poster child database smart feature is that it periodically collects instance and cluster-wide hang statistics and auto-tunes itself by considering metrics over a moving average. That is particularly important because it's very hard for an automated system to distinguish a hang from just a slow-moving process. And it's particularly difficult for Blocker Resolver because Blocker Resolver, being a database smart feature, can be operated on different systems, small or slow systems, big and fast systems. And depending on the system, a slow-moving process may be a slow-moving process or a hang, and that's exactly where the auto-tuning of Blocker Resolver comes in to be able to distinguish those cases. Now, unlike other smart features, Blocker Resolver has also what I would call a manual override. Blocker Resolver sensitivity can be set from normal to high if you think that Blocker Resolver could be more aggressive in resolving hangs, which could mean it would resolve a hang even though it was just a slow-moving process. Either way, Blocker Resolver is one of those features that provide business continuity smartness even with a manual override. Oracle Database 23AI accelerates this trend, meaning accelerates the trend of providing high availability or high availability features with business continuity smartness. And I could give you a number of examples. Unfortunately, I won't have the time today, but I want to mention a few features just so you see that business continuity features are used in Oracle Database 23AI. The first feature that I want to mention is globally distributed database with RAF-based replication, because the RAF-based replication allows globally distributed database to detect and react smartly and swiftly to a failure or an outage of a shard or its replica, so that it can fail over workload from the impacted shard or replica to another one to ensure business continuity swiftly, but also in a smart fashion. Priority transactions are another of those features that I could mention in this context. Priority transactions allow you to set priorities on your business transactions, either low or high. And if there's ever a shortage of resources in the databases, the database will make sure that those transactions with the higher priority can continue, potentially sacrificing those transactions with the lower priority, assuming that you made the right choice and you set the priority so that business continuity can be ensured. As I said, I unfortunately cannot talk about all these features today, but for example, for globally distributed database with RAF-based replication, there is a dedicated DatabaseWorld session, which I would encourage you to join if you are interested. For this session, I will be focusing on the 4 areas highlighted here in the middle of the slide. The first 2 are cluster-aware resiliency and Oracle X Smart Connection Rebalance. And they will basically extend and build on the examples I've already provided regarding smart fencing and database smart features. The other 2 areas of features, rolling database maintenance with application continuity and Exadata fleet update, I want to talk about based on feedback received from our customers that in the area of planned maintenance, business continuity smartness would be appreciated and perhaps even needed. And that's exactly what Oracle Database 23AI is focused on as well. Cluster-aware resiliency or Oracle Cluster-aware resiliency has been made smarter with Oracle Database 23AI with a number of features, 3 of which I want to talk in this slide. The first one is the automatic self-correction of host configurations. The configuration verification utility, CVU, provides baseline comparison, correction of file permissions in the grid infrastructure home, and automatic adjustments of the OS kernel parameters to recommended values. So every time you let the CVU run, it will make those corrections and thereby provide better resiliency for Oracle Cluster. The feature in the middle, last node standing despite network failure, may sound like a logical conclusion to you. It provides or enables the last node in a cluster to survive a private network or what we call interconnect failure. And you may think that this is something that we should have done years ago. The problem is that the smartness behind this feature needed to be developed and be executed at the moment of fencing. And that's why we have this feature with Oracle Database 23 AI. Last but not least, expedited server fencing on Exadata database machine. With expedited server fencing, Oracle RAC instance and server reconfigurations benefit from Exadata's hardware-assisted fencing optimizations to perform those reconfigurations faster and smarter. And using those and other features makes Oracle Clusterware a very reliant, sound foundation for Oracle Real Application Clusters, or Oracle RAC in short. Now, speaking about RAC, Oracle RAC has always tried to provide transparent high availability and scalability. Now, for the purpose of transparent scalability, it uses its unique cache fusion algorithm, as part of which it will always try to deliver the data to where the session is connected in the cluster. Take my picture here on the left. We have multiple connections, some connected to the rightmost nodes to the gray data, some connections connected to the leftmost node to the red data, and the white data block framed with red, which indicates that 3 sessions on the second but leftmost node would continuously access the red data, but 2 sessions, the 2 red sessions on the leftmost node, would occasionally access the red data. And what would happen historically in Oracle RAC is that RAC would go out of its way to deliver the red data to the leftmost node on which the sessions are connected. Now, sometimes it would be much smarter not always to deliver the data, but relocate the session to where the data actually resides in the cluster. And that's exactly where Smart Connection Rebalance comes in. Smart Connection Rebalance goal is to redirect session and the workload to where the data resides in the cluster. And it wants to redirect these sessions transparently, of course, and without manual intervention by the DBA. Now, unlike a lot of other smart features, Smart Connection Rebalancing is not enabled automatically. You would have to enable it, which is very easy to achieve. You simply need to set the runtime load balancing RLB goal service attribute to Smart Con, and you will immediately benefit from Smart Connection Rebalance. Now, Smart Connection Rebalance itself benefits from another enhancement, or a couple of enhancements, but one in particular that we have introduced in Oracle Database 23 AI, which focuses on the way we can relocate sessions. And that base enhancement is used in context of another feature called Smart Planned Failover. Smart Planned Failover allows the database to determine when to best failover sessions during draining. That bounds maintenance windows and makes it much easier to continue business after the need for a failover based on planned maintenance. The way we do it is by using draining. Draining allows applications to complete their work before performing maintenance, load balancing, or disconnecting. With Oracle Database 23 AI, the drain timeout, so the time the database will wait the longest before sessions need to be failed over, can be set on a per database service or per session basis. And during that time, the Oracle database will detect sessions that will not drain and can fail over. There are certain sessions that connect to the database and perform operations once connected to the database that lets the database predict that those sessions will not drain, meaning conclude their work in time. Those sessions can be failed over any time if there is an opportunity for it, because they will not finish anyway. So you might as well fail them over when an opportunity presents itself. And that is what the Oracle database will detect and then use. The Oracle database will also proactively choose failover sessions based on rules. So if there are certain sessions for which the database determines that they can be drained in that time and there is an opportunity, it will do so proactively. Both approaches bound maintenance windows because most requests will reach their failover conditions quickly. Now, if you combine those selected sessions and let them continue with transparent application continuity, you in addition gain a minimized ungraceful session termination. So there will be, most of the session will be failed over smoothly, and you reduce the replay time on failover. That means using Smart Planned Failover, you can ensure that business continues. However, whether it's for unplanned outages or planned failover, the best way or the most optimized way to continue the business is by automatically suggesting fixes based on proactive monitoring. And that's exactly where Oracle Autonomous Health Framework, or short AHF, comes in. AHF optimizes business continuity by proactively and constantly monitoring your system, the servers, the databases, the storage, the network, and suggesting fixes based on the data it collects. And it does that using different approaches, different models. It's a high availability compliance management solution that uses smart data collectors to collect data, which is then presented to you via the service console, but it's also used as part of a root cause analysis, or particularly when HF is used on the Oracle Cloud for automatic bug matching. With that said, HF can be used on premises and in Oracle Cloud, but what it really does is it uses familiar components, tools, products, components that most of you use or at least are familiar with in a more effective fashion. As a fully automated and integrated autonomous system health foundation in the Oracle Cloud, for example, which means it uses tools such as Exadata Check, Exacheck in short, AuraCheck, DBSet, Auto Upgrade, or the formerly mentioned CVU for verification and AHF compliance management. So it uses these tools and sets up a high availability compliance management assessment. But it goes further than that. It uses smart collectors such as the trace file analyzer, the cluster health monitor, and the OS watcher to collect data about your system. As I said, the servers, the network, the storage, the databases, and then uses the result of the compliance management tools and particularly also the smart collector data as part of a root cause analysis, for which it also uses the cluster health analyzer and the parser, which are machine learning powered tools, making it easier to slice and dice data. Last but not least, the data that it collects will be given to you via graphical user interfaces, AHF Insights and Fleet Insights on the service console. AHF Insights and Fleet Insights provide you with a dashboard, but using the smart collector data and the approach for the root cause analysis lets you drill into the data if you want to perform a more detailed investigation or a manual root cause analysis, and AHF will have means to assist with that one too. As I said, you can use HF on premises, but in the cloud, it's used as an autonomous system health foundation, specifically for autonomous database. And that is important to understand because there are certain areas that just don't change simply because you move your Oracle databases from on-premises into the cloud. One of those areas is providing high availability and disaster recoverability. Many of our customers have told us that on-premises, they have set quite sophisticated high availability and disaster recovery plans, which they now would like to transfer to the cloud as they are moving into any cloud, or particularly also the Oracle Cloud. Now, if it can't be transferred directly, then what alternatives are available in Oracle Cloud to help with setting up a disaster recovery plan as it was done on premises before? And that's exactly where Oracle Cloud Infrastructure, or in short OCI, Full Stack Disaster Recovery comes in. OCI Full Stack Disaster Recovery, or short Full Stack DR, is a smart disaster recovery service that allows you to provide fully managed disaster recovery for the entire application stack. So when you move your application, your database into Oracle Cloud, what Full Stack DR will provide you with is a means to set up a disaster recovery plan that not only considers and incorporates the Oracle database, it will also consider the application and the infrastructural pieces such as virtual machines, block storage, or file storage as you move into the cloud. What makes it a smart disaster recovery service is that it uses automatic DR plan creation and validation. So as you move your stack into the Oracle Cloud and you put various components into your DR plan, Full Stack DR will analyze your DR plan, validate it, suggest additional components to be protected, and then allow you to test your DR plan, after which another validation is possible, so that if disaster ever strikes, you're fully prepared for a failover as you have set it up via your DR plan. And you can do this in a unified management way. So the validation, the monitoring, and the execution of DR runbooks are all monitored and executed from a single pane of glass. Now, why that helps with high availability and disaster recovery, which are hopefully events that don't occur regularly, ideally never, it doesn't help with the formerly planned maintenance, because planned maintenance still remains a shared responsibility when you move your databases into Oracle Cloud. Let's assume you move your Oracle database from on-premises into an Oracle database service, such as an Exadata database service. Then patching and updates are still a shared responsibility. So you need to work with those systems to perform those operations on a regular basis. And that's exactly where smart updates with Exadata Fleet Update come in. Smart updates are powered by fleet patching and provisioning, in short FPP, which is an on-premises tool that has been used by our customers for quite a long time to optimize patching and updating of their single databases, single instance databases, or fleets of databases, cluster instance databases on premises. And the same capabilities of FPP are now being provided to you via Exadata Fleet Update, which allows you to save 38% of the steps measured in the number of screens to update a single database, and more than 88% of the efforts to update 6 or more databases, which we therefore will call a fleet. How is that possible? Exadata Fleet Update allows you to set up an update or patching plan for one database, but then also allows you to apply that one plan to as many databases as you'd like. So if you have 6 or more databases to update in the same way, you can save more than 88% of the effort, because you just have to say, Exadata Fleet Update, please apply this plan in a scheduled fashion, for example, to all those databases that you list. The smart update then comes in by Exadata Fleet Update using a standardized approach, including new feature support, fully maintained by Oracle, which means, is there ever a change in configuration? You just have to tell Exadata Fleet Update or FPP that there is this configuration change and it will accommodate for it. Or if there is an enhancement in features, for example, because we have a new database release coming out and there are new features, then FPP and Exadata Fleet Update will automatically account for those and make changes in the update or patching as required. FPP and Exadata Fleet Update also allow you to perform group operations, including database service management and advanced rolling update options, such as you can roll a patch by one node in a cluster at a time, or you can define groups of nodes in the cluster that you want to patch at once. You then can schedule those updates or patches, and regardless of whether you use Exadata Fleet Update or FPP, they always use out-of-place patching, which means operations such as resume, revert, or rollback, should they ever be needed, can be automated and be executed much faster. So in that way, you have ensured business continuity the smart way, because you took care of updates and patches in a smart, efficient way. So in summary, business continuity is an absolute requirement for any business, big or small, operating around the clock. Oracle Database's smart features help to ensure the highest levels of high availability, scalability, and disaster recovery of databases and applications. Oracle Cloud, including Exadata Cloud Services and Autonomous Database, benefit from additional smart features in engineered systems and the integration with the Autonomous Health Framework as shown. If you have any questions about the technologies I spoke to today or about business continuity the smart way, please do not hesitate to reach out to me either via the email provided below or one of the social media links. Until then, thank you very much for staying with me. Enjoy the rest of the show. Thank you.